Hi friends, this is Rakesh and today we are going to see how to analyze lean truss system using ANSYS Classic. For that, go to preferences and select structural and press OK, and then go for preprocessor, then select the element type, say add, edit or delete, and say add here and select the link 3D finite string and say close. Now we have to define the real constants. Because this is a 1D element, you have to provide the area of cross section here as a real constant, and you see all the three trusses have the same area, so that is why we are going to only get one real constant set. Say real set add, press OK, and here we are going to give the area which is around 2000 e minus 9, right? Press OK and say close, right? And then we go for the material properties, add material models, go select structure, linear, elastic, isotropic, and then give 200 E9 for Poisson's ratio, and then here this is 200 E9 for Young's modulus, and keep 0 for Poisson's ratio. Press OK, and now you can exit it. Then we have provided the element type which we are going to use and real constants for that elements and the material properties for the elements. Then we have to model the mesh and elements. For that I am going for modeling, say create, say nodes in active coordinate system, and I am going to create the first node at a height of 4, at an height of 4 from the origin in the y direction, at a height of 4 from the origin in the y direction. For that I will press 4, enter 4 here and say OK. Then again I will select this one, and now I will press 3 and 4 to create the next node, the second node, and I want to create the third node at the origin. So that's why I have left everything 0 0 0. Now I have created the required nodes. Now I will create the elements. So for that, go for elements, say auto number, say through nodes, and you will select this one. And the selection of nodes here should be careful, because in the truss system it depends upon the connectivity, node connectivity, and the element depends upon defined nodes, right? And the element, for the element 1 select 1 and 2 node, press OK, apply, and then for the second one you select 1 and 3 and say apply, and for the third one you select 2 and 3, say OK. So we have created all the 3 elements. Now what we have to do is we have to give the supports. For that, go for the loads, say define loads, go for apply, go for structure, say displacement, and say on nodes, and select this one, this node, and say you have to take off the ux and uy displacement as well. And now here on this node and this node I want to constrain uy, only uy, so I will select only uy and say OK. Now if you see, according to my problem, this is not in a standard orientation with the, as like in the standard global coordinate system, it is at an angle, it is at some angle. So what I have to do is I have to place an angle constraint, angled constraint on that. For that what I will do is go for the work plane, say go to local coordinate system, say create local coordinate system at the specified location, and I will select this point as my specified location, as if I want to create a local coordinate system there, and I will rotate the global coordinate system in with respect to z, uh, at an angle of 53.13 and press OK. Now if you see, the present coordinate system is 11, it became 11, that means the new local coordinate system which we have created. So but if you see, this constraint has not align with the new coordinate system. For that, what we have to do is we have to go for modeling, go for move and modify, go for node coordinate system, and say to active coordinate system and select this node, because I want only that node to go for the local coordinate system which I have created. Press OK, and now just say replot. So you see my support is in is at an angle now, right? So now what I have to do is I have to apply a force here on this node, force on this node. So for that, what I will do is I will go for the loads, go for the define loads, apply structure, and then displacement. I will take force and say on nodes, and I will select this node and say OK. And my node is in fx direction itself, and the load is around 200 into 10 to the power of 9, 200 into 10 to the power of 9, which is nothing but 200 GPa. Sorry, it's 200 I think it's 100 kilonewton, sorry, excuse me, it's 100 kilonewton. So 100 E3, 100 E3, because here we are putting everything in meters. So okay, press OK, right? And now after that we will solve the problem by going to solution, say solve, run close step, press OK and say close, right? The solution is done. Now go for general pre-processing, post-processing, and go for list results and see the reaction loads, because this is one of the thing which we, one of the interesting thing we want. So if you see, we got the or different reactions at different constraints or boundaries, different boundary conditions, like for example at this fixed and at this one, right? Different supports. Now what I have to do is I want the total displacements on the elements. So for that, what I will do is go for the list results, go for element solution and say a stress, go for x component of stress, and you can see here that we get the x component of stress, which is around, I think, which is around 5e11 minus 5e11, right? That means it's a compressive stress. Okay, it means it is a compressive stress. Now what I have to do is I have to see the deflections. I have to see the deflections. For that, what I will do is I will go for this nodal solutions again, degrees of freedom, say x component of displacement, say OK. So here you can see the nodal displacements in the x direction, the nodal displacements in x direction, right? And now I want to see the nodal displacements in the y direction. So what I will do is again check this nodal displacements and say instead of x component of displacement I will place y component of displacement and say OK, and here I got the y component of displacement. Okay, then you can also check the solution by referring to the supports that you have placed and the constraints you have given, right? Again, third one is we want the stress, and we have seen the stress as well. So for that, go for the element solution once again and say I want to see 1 meter stress. Say okay. So here is the 1 meter stresses, right? So this is what I want, and uh, this is what I want, and right. So I think I can provide an elemental table as well, define table, say add, say some stress, right? And go for this the sequence number and say ls1, right? Say okay, and say close and say plot element table and say this is the element table, say list, say go for stress, say okay. So here you can see the stress values that are present inside the element, minus means compressive, and you can say it's a plus means tangential. So you say what